Hey guys, this is acservicetech, and today what we're looking at is the safety controls on a older 60 to 70% efficient forced air gas furnace with an intermittent pilot control, or even if it's an 80% efficient with an intermittent pilot control. After I show you this firing up, I'm going to go ahead and show you an up-close image of what this looks like, because it's actually checking for flame rectification in this area right here. The issue is it's not checking it over here or over here. And these classically, what you're going to find is, you have some rust buildup, okay, due to the condensation or water vapor that occurs during the flame process. This one has larger holes, but other ones that I've seen end up having some issues with this. They end up closing up. But I'm going to go ahead and turn this on just so you can go ahead and see it. So you had your pilot light right there, and then after that, the ignition control, allowed voltage to the main gas valve to allow gas through each of these burner assemblies. So the issue still stands that it's only finding, or as far as the safety is concerned, it's only finding it right there near the pilot, and it's not finding it on the burner, say over here, okay? Say over here somewhere. It's not finding it over there. All right, I'm going to back this up and show you a couple other things here. I'm going to go ahead and turn the heat off. Okay, so this valve right here has a pilot assembly. This is a pilot assembly and a main gas ability right here. Okay, you can turn it on and off via right here. And what you have is you have the pilot valve is powered with 24 volts right here, and the main valve is powered with 24 volts right here. This MVPV right here, that's the common, all right? That's the path back, and you have jumpers, jumpering these out on the gas valve here. Anyway, so this is the ignition control. The ground right here is going to be where you're sensing your flame rectification signal at. All right, for the most part, it can actually sense it still, but you're going to have intermittent problems if you do not have a good ground. All right. So we're going to go ahead and take a look at the actual igniter itself. You have this right here is the wire I'm about to show you, and it's sending roughly about 6,000 volts to the spark assembly. And the sense right here, it says sense. This is actually, even though this is 24 volts, it's sending 130 volts to the flame rod. And then you're having the flame rectification process go from there. And this board is sensing for a DC microamp signal coming back on the ground. Right, this ground is connected to the common. Okay, guys, we have this right here is the sparker, okay, and it's very, very close to this pilot tube assembly, the termination for the pilot tube. All right, so what we're looking for is about it says on the control about 7/64ths of a gap between here and here in order to spark that 6,000 volt spark, make it across from point A to point B. All right, so it's going arcing onto the ground. Then you have this flame rod right here, and this flame rod sending 130 volts on this particular control into the flame, and it's coming back to this right here, okay? Then from here, it travels to the ground, basically connected to the gas valve. Then you have that ground wire on the control picking it up, picking the DC microamp signal up. All right, but it's all done right here. So what happens if you have part of, say, this burner right here rusting shut? And I've seen these rusting shut, maybe part halfway down the tube. That's a problem, okay? But basically, that's why they don't use these anymore. They were good for the time, but now I'm going to show you what more of the modern flame rectification proving situations look like on the newer gas furnaces. So on this furnace, what you have is you have a gas valve that is just powered with 24 volts, and the gas flows through right here, in through each of these orifices, through the burners, all right, and then into the heat exchanger. Right here, these two wires right here, those are wires that are connected to the hot surface igniter, and that turns cherry red, and it lights these burners over on this side here. and then the flame travels along a channel until it reaches all the way over here. All right, it does that because it has this little channel. All right, so you have each of these burners sit right next to each other, and you have this little gas channel right here that it can go across. And so you can see it's actually bent right here, and that's what allows the flame to travel across horizontally until you get over to the flame rod. I'm going to take the flame rod out for you just so you can see what that looks like. So this is positioned right in front of the flame. All right, this is what you would use unsoaped steel wool for this, a fine coarse on there. All right, but that sits right in the flame, and you have 100 and maybe anywhere from say 90 to 110 volts going into the flame, and then the flame rectification process proves itself on the burner retention head and finds its way back through the ground wire until it gets back to the control board. And the DC microamp signal can be measured at the ground wire or the control board. All right. It can also be measured in series with this flame rod. All right. You can check out some of my other videos on flame rectification and how that works, but I just want to explain how safe this is compared to that intermittent pilot controls. All right, some of those older furnaces that you'd see a natural draft 60-70% efficient furnace or 80% efficient furnace. This one right here happens to be the say a 95% efficient condensing gas furnace. So it's 95% efficient transferring gas to heat. All right, but that's how that works, and that's how these are much safer. So make sure that every one of these burners is lit before it will allow it to continue. This happens to be a Bryant carrier pane unit, and so the gas is only allowed to travel through here for 3 seconds before the control board picks up the flame rectification signal provided through the flame via this flame sensor rod. You can use unsoaped steel wool, a fine unsoaped steel wool, to clean this as part of a preventative maintenance. You don't clean the hot surface igniter. All right, you don't want to touch that really. But I just want to make sure I went over those safety controls and how the newer furnaces proved it as a flame much better than some of those older furnaces with the intermittent pilot control. All right, hope you enjoyed yourself. We'll see you next time at AC Service Tech channel.